Okay, resistors and circuits. So we've done voltage is the driving force, current is the flow of electrons, resistance is how difficult it is to make electrons move down a wire. We've got Kirchhoff's laws for voltage and current that give us some guidelines on how they behave. And our second last step here is how do resistors behave when they are in a circuit. So if you see here, I have 3 resistors in a series circuit, and the important part to remember of this is that the voltage, the circuit itself, doesn't know that there are 3, it just knows there's resistance. Okay, and that combined resistance is what the source has to deal with. So we might see them being as 3 resistors, but the source just sees it as being there's some total series resistance in this problem, and that's what governs the current that it sends out. Okay, so what we're going to look at today is how do we maneuver or rearrange some of these values so that they become easy to work with from a calculation standpoint. So we're going to talk about equivalent resistance. So that's, for example, we could take 3 resistors here in this left diagram, and we're going to turn it into an equivalent 1 resistor so that when we're making calculations, that's an easier approach to do. So if we combine Kirchhoff's laws and Ohm's laws, if we start with the Kirchhoff's law for series right here, you can see we have all of the voltage drops and gains have to add up to our starting source amount. Okay, so now if I combine that with Ohm's law, so if I take Ohm's law, V equals IR right here, and I replace all those V's with IR combinations, and then we can see that, well, all of these I's, because this is a series circuit, all of those I's are the exact same value. So we can cancel them off. Okay, so mathematically, once all of those cancel off, we are left with the total resistance, or the series resistance, the equivalent resistance, is just the sum of the resistances that are in series. So if we have, as the above example has, if we have 3 resistors, we would add up all 3. If we have 5 resistors in series, we just add them all up. Okay, so that's our first equivalent resistance relationship. So here we go. 4 resistors are connected in series, so that's an important distinction. The resistances are as follows: R1, R2, R3, R4. Calculate the equivalent. So we would have R series equals 41 plus 51.75 plus 11.1 plus 102.008, just to be difficult. Okay, and then the series resistance, the equivalent resistance, you would just add those up. Do that really quickly. Now why they chose that ridiculous last number, I don't know, but we can deal with it. So we're looking at about 206 ohms resistance would be equivalent. Okay, so if you want to pause it and just try the next two, they're pretty quick. Okay, so what is the equivalent resistance for a 25 ohm resistor connected in series with a 28 ohm resistor? We add the two together, you get your 53. What is the equivalent resistance for 3 53 ohm resistors connected in series? Just add up all 3, should be 159-ish. There we are. Okay, so series is pretty straightforward. Parallel, it's a little more challenging. Okay, so we have our parallel circuit over here. We have 3 resistors in parallel, and again, the source doesn't see that there are 3 pathways, it just knows that there's resistance. Okay, and this one is not intuitively obvious. It takes a little bit of thinking to approach this one, so we'll go through it a little bit slower. For a parallel circuit, we know that the sum of the currents has to total what we start with. Okay, so we're going to take that and we're going to again combine Ohm's law, only we're going to do a rearranged form. Okay, so we have I equals V over R, and we're going to substitute that back into Kirchhoff's. Okay, and then we're going to take a look at this expression right here, and what we should notice is that all of the V's are the same. So the source and the voltage over each one of these pathways should match up. So when we do that, you can see we've replaced down here, we've replaced all of the I's with V over R, and now we can cancel all of these, and we're left with this relationship. So 1 over R parallel equals 1 over R1 plus 1 over R2 plus 1 over R3, and however many R's there are. Okay, so that is our parallel relationship. So now I'm going to warn you, this is the one that has the most mathematical mistakes in it, predominantly because of this term right here. Okay, it's 1 over R parallel, it is not R parallel. And I'll show you where that mistake comes in. So this is how I would start it. 1 over RP equals 1 over 15 plus 1 over 12 plus 1 over 10. Okay, now if you have a calculator that can do fractions, if you're comfortable, we could look at this one and use, what, 120 I think works. 15 times 8, yep. So we could get a common denominator. So I would make this one 8 over 120 plus 10 over 120 plus 12 over 120. We total all that up, and we have 10, 22, 30 over 120, which is the same as 1/4. And now here's where most people make the mistake. They say the resistance is 1/4. It's not. Okay, so if we have 1 over RP equals 1 over 4, then RP, the parallel equivalent, is 4 ohms. Okay, you could do some cross multiplication, you can do some rearranging, you can do solving by comparison, and this is the one that gets most people because they do not finish the last line correctly. And what's really counterintuitive is if you look 15, 12, and 10, all of those individual resistances are greater than the equivalent parallel resistance. So that's something to note. Put that in on your radar. That's where most people make their mistakes. And then you can pause it and try these two, and we'll see how well you do. Okay, so let's take a quick look. What is the equivalent resistance of a 120 ohm resistor connected in parallel with a 60 ohm? So 1 over RP, 1 over 120 plus 1 over 60. This is a P. Okay, so I'm going to use a common denominator here because I think that's fairly quick to do. Got to keep writing that as 1 over. That's really important. 3 over 120. And we'll go down a little further here. Now, you might find you want to rearrange this. That is totally fine. Looks something like that. And then you end up with 40 ohms equals the equivalent parallel resistance. Okay, so if we go up here, let's take a quick look. There's 40 ohms. What is, let's do the next one. What is the equivalent resistance of 4 20 ohm resistors? Okay, so 1 over RP. Now we could do this plus plus a whole bunch of times, or we could multiply them. Okay, but we'll do this. There's my 4 120s. 1 over RP becomes 4 over 20. 1 over RP, oops, went right off the screen. RP is 1 over 5. RP is 5 ohms. Cool? Okay, so please make note that line there to there is where most people make their mistakes. Okay, so let's put this in a action on how we're going to use this. Calculate the equivalent resistance for the circuit shown. Okay, so we have all of these resistors. So what we're going to do is we're going to approach this in a couple of steps. We are going to take, and I'm going to redraw it, we have this guy, and then we are going to replace all of the parallels with whatever the equivalent R parallel is. Okay, so I come down here, I do my R parallel. I have 1 over 75 plus 1 over 50 plus 1 over 30. Now, if you're comfortable on your calculator, you could actually do this as well. If you don't lose any of your decimals, it is possible just to do the divisions. Okay, and you would have 1 over RP equals 0.066 repeated. Okay, and again, if you don't lose your decimals and then you use your 1 over x button, you can get RP equals 15 ohms. Okay, again, you can try it on your calculator, try it with fractions, find a method that works for you. Okay, so now we have 12 ohms on the top, 15 ohms equivalent for the parallel, and 18 ohms for the bottom circuit. And now the total, you might want to use a T or an S for series. If we add those all up, 12 plus 15 plus 18, the series or the total for this circuit, the equivalent would be 45 ohms. Okay, so you attack these guys first, turn them into an equivalent parallel, and then turn them all into, I'll draw it here, then we'll turn them all into one equivalent resistor here. Okay? Alright, so I'll let you try these two. Okay, so if we come back here, see what we're doing for time. I think we're okay. So if we approach A, you'll notice there's parallels in there. I'm going to go after those first. I like to redraw all of my circuits even quickly. So if these are all fives, and this guy is RP. Okay, so I have to be careful. It's 1 over RP equals 1 over 5 plus 1 over 5. 1 over RP equals 2 over 5, and you might find some math shortcuts as you go through this. I'm going to just do it all longhand just to make sure everybody can see where we're going. Okay, if I cross multiply, simplify, RP is 2.5. Okay, so the total for this guy, the R total, would be the 3 5s added together plus the 2.5 for a total of 17.5 ohms. Cool. All right, let's jump to the next one. Okay, I'll leave that up there for a second, and then we'll erase to double check. There's A, there's the 17.5 we got. Okay, and now let's do the next one. I'll clear the screen and do it from scratch. Okay, so now I have 4 R's in parallel that I want to deal with. Okay, so I'm going to cheat a little. That's 4 1 over 5s, or 4/5. Okay, so RP is equal to 0. Nope, not 0. Sorry, there, I almost made that mistake that I... Okay, this would be cross multiply 5 over 4. There we are. And so RP is equal to 1.2 ohms. Just double check my thinking there, make sure I'm good. 1/5, 1/5, 1/5, 4/5, flip it over, 5/4, I like that. Okay, and then R1 is 5 plus 1.2, so we should get a total of 6.2 ohms. Okay, now the takeaways from this, and this is getting into electrical engineering and all those types of things, is that you can take the same resistor, in this case we just used 5 ohm resistors, and we were able to generate 6.2 ohms, 1.2 ohms. We could do a whole bunch of different things. If we put them all in series, we could have a maximum of, say, 25 ohms. So understanding circuit relationships, you can create all of these different resistances within a problem and using one type of resistor. It's pretty amazing stuff. Okay, so there's the summary. If you could try section 11.8, number 2 and 5. Okay, have some fun with it. Just watch for that 1 over RP. That's the one that gets most people.